All right, let's get into it. We're going to completely change how you look at a simple journey. I mean, what if I told you that any trip, whether you're just walking to the store or driving across the country, could be boiled down to a single, easy-to-read picture?
I mean, just think about it. Motion is literally everywhere. From an athlete just flying down a track to that, slow, agonizing crawl of a car in traffic, movement is just a constant part of our world. We're always going somewhere.
Okay, but what does a journey like that actually look like? How can we take all that movement and turn it into a picture we can understand at a glance? Well, that's exactly what we're going to dive into. To do this, we're going to use this really powerful tool called a distance time graph. And yeah, I know, it sounds a little technical, but trust me, the basic idea is actually super simple.
It's really simpler than it sounds. The best way to think about it is like a storybook for a trip. The line across the bottom, that's just time, ticking by. And the line going up the side, that's the distance you've gone. It's that simple.
Okay, to really see how this works, let's imagine a car. And this car is on perfect cruise control, right? It's moving at a steady, constant speed of 4 meters per second. No speeding up, no slowing down, just smooth sailing. So, let's put this on the graph. At the very start, 0 seconds, we're at 0 meters. Makes sense. After 1 second, bam! The car's traveled 4 meters. After 2 seconds, it's at 8 meters. See the pattern? Now when you connect these points, you get this perfectly straight line, sloping up. And that line is the story of our car's journey.
Okay, and this is the most important part, so listen up. The steepness of that line, what we call the slope, that tells you exactly how fast the car is going. It's the whole secret right there. The slope of the line is the speed.
Think about it. A steeper line means a higher speed, right? You're covering way more distance every second. And a shallower, less steep line, that means you're going slower. It's a perfect visual for how fast something's moving.
Okay, that's great for a perfect, steady trip. But what about the real world? What if our journey isn't so simple? What happens if the car stops or even turns around?
Let's say our driver has to pull over for a minute. Time is still passing, right? The clock doesn't stop. But the car's distance from where it started, that's not changing one bit. So what does the graph do?
You got it. The line just goes flat. It becomes a horizontal line. Why? Because while time is moving forward, the distance isn't. So if you see a flat line, it means one thing. The object is stationary. It's not moving.
All right, new problem. The driver just realized they forgot something and has to turn around. They're heading back to where they started. What do you think happens to the graph now?
Well, the line starts sloping down. It's heading back towards the bottom of the graph. This makes perfect sense because the car's distance from its starting point is decreasing. It's getting closer to 0 again. So a downward sloping line shows the object is moving backward.
So far, so good. But in the real world, we don't always move at one constant speed, do we? We speed up and we slow down. So let's kick it up a notch and talk about that.
Most of the time, our speed changes, and that change in speed is called acceleration. When you accelerate, you're not covering the same distance every second. In fact, you cover more and more ground as each second goes by.
So if your speed is changing, you can't have a straight line anymore, right? A straight line means constant speed. Instead, what you get is a curve that gets steeper and steeper as you go faster and faster.
And you see this acceleration curve all the time. A car taking off from a stoplight, for instance. Or think about a ball you drop from your hand. It gets pulled down by gravity, going faster and faster. That's acceleration.
You know what's really cool is this number right here, 9.8 meters per second squared. That's the acceleration due to gravity, right here on Earth. It's a perfect real-world example of the force that creates that classic curve when something falls.
All right, so now we've learned the language of these graphs. We know what all the different lines mean. Let's try putting it all together and see if we can decode a whole journey. These different shapes, the straight lines, the flat lines, the curves, they're basically the visual building blocks for telling the story of any trip. Each one tells you a piece of what's happening. So, this is basically your cheat sheet. An upward slope, you're moving forward at a constant speed. A horizontal line, you're stopped. Downward slope, you're heading back. And an upward curve. That means you're accelerating, you're speeding up. And when you put all these pieces together, you can tell the story of a whole complex journey. You can see when they started, when they stopped, when they turned around, all of it, just by looking at one graph.
So now it's your turn. You've got the tools. Take a look at this graph. What story does it tell? Look closely. What's happening at the beginning? Can you spot where the object stopped? Did it accelerate? All the answers, they're right there in the lines.